Good morning and welcome everyone. Thank you for being here for CCST's Expert Briefing on the many impacts of drought in the California Delta. My name is Sarah Brady. I'm the Deputy Director at the California Council on Science and Technology. I'd like to open our briefing today by acknowledging that I'm presenting to you from the tribal land of the Nisenan people. Sacramento was a gathering place for many local tribes. We acknowledge the Southern Maidu people to the north, the Valley and Plains Miwok peoples to the south of the American River, and we'd also like to honor the Patwin Wintun peoples to the west of the Sacramento River. Today, I'll briefly introduce CCST and our Disaster Resilience Initiative and quickly hand it over to our moderator and expert panelists. CCST is a nonpartisan, nonprofit organization established over 30 years ago at the request of the California legislature. CCST was created to provide science and technology advice from the wealth of outstanding academic and research institutions in our state directly to policymakers. California is really lucky to have such an incredible network of expertise. And our job at CCST is to help amplify and translate the expertise in this network into actionable advice for policymakers. We do this through a number of mechanisms, including briefings like the one you're attending today. We host workshops, write peer-reviewed reports, and run the CCST Science Fellows Program, where we place PhD scientists and engineers for a year of government service and leadership training in the executive branch and legislature. As part of our mission, CCST has launched our Disaster Resilience Initiative to help the state better prepare for and respond to ongoing, complex, and intersecting disasters. These include climate change, extreme heat, power outages, and the COVID-19 pandemic, which are radically disrupting the ways in which Californians live and work. These disruptions, while often destructive and painful, can provide us opportunities to redesign our systems to be more resilient and sustainable. So through our Disaster Resilience Initiative, we seek to deliver science and technology advice to reduce harm and improve the lives of all Californians. Today, we will be focused on the compounding and cascading impacts of drought in California's Sacramento-San Joaquin River Delta. Addressing these impacts can help California meet its disaster resilience goals. I'd like to introduce our moderator, Dr. Laurel Larson, Delta Lead Science for the Delta Stewardship Council, an Associate Professor of Geography and Civil and Environmental Engineering at the University of California, Berkeley. She's an expert on hydroecology, landscape dynamics, and environmental restoration. Take it away, Laurel.
Thank you, Sarah, and good morning, everyone. Drought in California has many negative effects on water availability and water quality to end users. In fact, typically when we think about drought in California, we think dry reservoirs, poor water quality, and wildfire. However, there's a cascade of other impacts that drought sets off, as resource agencies and scientists have seen firsthand over the last decade. Some of these impacts were previously unforeseen, and some are long-lasting, persisting for years beyond the end of drought. These impacts may, in fact, alter the way our system responds to the next drought. One region here in California where the impacts of drought have been most concentrated is the Sacramento-San Joaquin Delta. Drought impacts have been outsized here, not just because the Delta represents the convergence of waters originating over a watershed that constitutes a majority of the state's landmass, but also because of the Delta's economic importance. Water pumped from the Delta supplies 2/3 of Californians and irrigates 45% of the fruits and vegetables produced in the US. Additionally, 80% of California's commercial fish species rely on the Delta. Truly, impacts of drought on the Delta have far-ranging repercussions, and success in figuring out how to promote resilience in the face of these steep challenges in the Delta can provide a valuable model for the rest of the state and beyond. As you will learn today, impacts of drought on the California Delta have led to new areas of investigation and management practices to address issues involving water quality, ecosystem-based management, public health, and more. Today, I have with me 4 experts working on investigating and addressing the many impacts caused by drought in the California Delta through research programs and management practices in order to build a more drought-tolerant delta. I am now going to invite all of the panelists to give a brief introduction of their expertise and discuss a specific challenge that they are working to address. And I will start with Dr. Shruti Khanna, who is a senior scientist with the California Department of Fish and Wildlife. Shruti, welcome.
Thank you, Laurel. Hi, I'm Shruti Khanna. I work for the Department of Fish and Wildlife for the Bay Delta Region 3, which includes the Bay and the Delta. And while I was doing my PhD in ecology at UC Davis, I have been working in the Delta with remote sensing imagery, mapping invasive species that have spread in the Delta since 2004. Rather, I've been studying them since 2004. I've also looked at how these species behave during droughts and how they are affecting the environment. So that is basically my background with these, with the effect of drought in the Delta. Thank you.
Thank you, Shruti. And next I will introduce Dr. Michelle Leinfelder-Miles, who is Delta Crops Resource Management Advisor with Cooperative Extension, a statewide UC program with the Division of Agriculture and Natural Resources. Michelle, welcome.
Thank you, Laurel, and thank you to CCST for the invitation to present today. My name is Michelle Leinfelder-Miles, and I'm a Cooperative Extension Advisor with UC's Division of Agriculture and Natural Resources. Through partnerships with county governments, Cooperative Extension Advisors are based throughout the state and develop research and extension programs to support local communities. As the Delta Farm Advisor, as I'm locally known, I am based in the San Joaquin County Cooperative Extension Office and work on issues related to crop production practices and soil and water resource management throughout the Delta region. I have a bachelor's from UC Davis in crop science and a master's and PhD from Cornell in horticulture. And in addition to my educational and work background, I also grew up on a farm in San Joaquin County. So I'm back in my old stomping ground. Thanks.
Thank you, Michelle. Our third panelist is Dr. Josué Medellín-Azuara, who is Professor of Civil and Environmental Engineering at UC Merced. Josué, welcome.
Thank you very much. As Laura said, I'm a member of the faculty, and my research group works on water management issues under climate extremes, including droughts, and their economic effects on agriculture, communities, ecosystems. And through the years, I have conducted research in the Delta on various topics, including water use and water management for agricultural production and communities. And I'm really honored to be part of this briefing. Thank you.
Thank you, Josué. And our fourth panelist is Dr. Daniel Swain, who is a climate scientist with the Institute of Environment and Sustainability at UCLA. Daniel, welcome.
Thanks for having me. As Laurel mentioned, I'm a climate scientist, which means I kind of take the top-down approach to things, literally thinking about climate change from an atmospheric perspective. And sometimes I like to say I'm a bit of a reformed meteorologist in the sense that I really take a very weather-centric or episodic approach to climate change, really thinking about individual extreme events and the kinds of impacts they have on different systems. I got my PhD at Stanford in Earth System Science, and before that was at UC Davis for my atmospheric science degree. So I've sort of bounced around in a bit of a triangle around the Delta over the years. Geographically, although today I am speaking to you from Boulder, Colorado, because my secondary affiliation is with the National Center for Atmospheric Research, which is located here. So happy to be here.
Thank you. Well, it is a pleasure to moderate a panel of these 4 powerful experts, and I'm looking forward to the conversation today. For the audience members, please use the Q&A feature to submit your questions to our panel, along with your name and affiliation, and I will read out the questions to the panelists. But I'd like to kick off our discussion, first of all, by asking each panelist to describe some of the ways that drought impacts the Delta. And I'm going to start with Daniel. So please describe for us some of the ways climatically in which drought impacts the Delta and what to expect looking forward.
I think the first thing I like to talk about when we're talking about drought is to emphasize that drought is not an event that occurs really over a small area. You can have a flood that affects one watershed. You can have an earthquake that affects one city. But droughts are almost always going to be spatially and temporally broader than that. And so usually when there's a drought in the Delta, there's a drought throughout, at a minimum, most of California, and as is the case presently, often throughout much of the West. So not just one watershed, not just a cohesive set of watersheds, but actually a whole broad region that have very different climates, geographies, and watershed characteristics often share the experience of drought simultaneously, which of course makes it more complicated to manage because it means you can't just draw upon water in some immediately adjacent region where it's abundant. The other thing as a climate scientist that I talk about in a drought context more and more is the role of temperature. Now, it's obvious that to be in a drought, you need some degree of below average or low precipitation. So there needs to be less water falling from the sky, essentially. And it used to be historically that droughts, some of them were hot, some of them were cold, some of them were in between. But these days, all the droughts we're seeing are hot droughts. And increasingly, and somewhat surprisingly, I would even say, the impact of that rising temperature is becoming sort of outsized relative to its historical contribution. And increasingly, we are seeing droughts whose severity are temperature driven rather than precipitation driven per se. And so the main reason we're seeing more frequent and more intense droughts in places like California and the American Southwest is the direct effect of rising temperatures on evaporation rather than large changes in the overall amount of precipitation. There are other things going on that we can talk about later with seasonality and intensity and frequency of storms, but really it's temperature that's driving some of the magnitude of the droughts. And of course, the rising temperatures are also driving a lot of the ecological impacts, both in the Delta and in California's other ecosystems and watersheds, whether it's through water temperature being too warm for fisheries or because the landscape and the soil itself is drying out so much that it's resulting in ecosystem shifts of the vegetation on land or drying of the vegetation that makes it more liable to burn at a high intensity in wildfires. So it's affecting everything from wildfire severity to fisheries viability, and everything in between. And the Delta is kind of at the geographic center of this, and fairly literally, it's sort of aggregating the impacts to the west, to the north, to the east, and to the south.
Thank you for that overview. Compounding is certainly an apt adjective when we think about the effects of higher temperatures on drought here in the Delta. I'm going to pass it off to Josué to tell us a little bit about how these drought impacts that Daniel spoke about affect communities in the area.
Yes, I really like the way that Dan put this. Droughts in the Delta occur in the context of what is happening elsewhere in the state, particularly in the Delta draining basin. So diversions upstream, drainage, as well as exports drive salinity and other conditions that feed back into farming and water treatment needs for communities and cities and flood management action. So despite the Delta having relatively firm water rights compared to other areas in the state, the droughts in the Delta occur in the water context occur more on the water quality side of things. So lower flows may occur concurrently with elevated salinity levels, and this might affect crop viability, increase treatment costs for water for cities and other places. And this cascades at the end to profitability of agriculture, treatment costs, and employment opportunities that might switch in some areas that are particularly more volatile in terms of salinity conditions. So this might affect some of the decisions in the communities in terms of employment and activities, commuting, and other effects that compound with lower flows or changing water quality conditions in the delta. So these are some of the things one might want to think when we see some changes in flows and water quality in the delta.
We may have lost Laurel, but I'll take the next stab at the question as I can tag on to what Josué has been talking about. So drought impacts agriculture in many ways. For example, perhaps the most obvious way is with reduced water availability for irrigation and less soil moisture for crops to use, particularly tree and vine crops between irrigation events. But drought affects agriculture in the Delta in some unique ways and perhaps less obvious ways. Essentially, there's always water flowing through the Delta, so water quantity is not necessarily the issue during drought, though I'll come back to this point in a moment. Rather, it's water quality, particularly salinity, as Josué mentioned, that impacts Delta agriculture. Flows from the upper watershed push back ocean saltwater to protect water quality in the Delta and for the Central Valley and state water projects that deliver water to users south of the Delta. When flows are reduced, the salt and freshwater interface moves further inland and impacts the quality of irrigation water. The salinity of irrigation water can impact crop growth directly, and both the crop species itself and the crop stage of development may impart different degrees of salinity sensitivity or tolerance. But also when irrigation water is applied to fields, salts are added to the soil. Salts accumulate in the soil at higher concentrations than they existed in the applied water. And because soils are not homogeneous, salts may accumulate disproportionately depending on soil texture and layering. In other words, salinity may have fairly immediate outcomes on crop development, but the long-term impacts on soil quality are harder to quantify. One of my research interests is learning how to sustain or improve soil quality, and this includes investigating how surface water salinity impacts soil quality. I'll wrap up by referring back to how water quantity is generally not a problem in the Delta, but back in 2015, Delta growers were involved in a voluntary curtailment program that restricted water diversions, and a newer mandatory curtailment program is in place today. So both water quality and quantity can be impacts of drought for agriculture in the Delta.
Thank you, Michelle. And my internet has completely gone out, so I'm on my phone now. But we will now go to Shruti, who could tell us some of the impacts of drought on Delta ecosystems.
Yeah, so the Delta is home to endangered species such as the Delta smelt, the longfin smelt, Chinook salmon, especially winter-run Chinook salmon. And it is a critical resting spot for many species of birds that migrate along the Pacific Flyway. In drought years, especially hot droughts, as Daniel was saying, there can be stress to fish due to high temperatures, which can change their behavior and cause fish kills. Drought also leads to an increase in invasive aquatic species like submerged and floating plants, which change the Delta habitat in critical ways. They can cause low dissolved oxygen in the water, making it hard for the fish to breathe, and slow down water and make it less turbid. Predators are able to hide in the vegetation mats, and while the clearer water makes it hard for Delta smelt and other endangered species to hide from their predators, the predators find it easy to hide in the vegetation mats. So what we have observed is over the past 3 decades, invasive species have significantly changed the habitat quality in the Delta. And with the increasing frequency of droughts, and especially hot droughts, this can only get worse.
Thank you very much, Shruti. Well, I'm going to go on to our first question from the audience, and that comes from Assemblyman Carlos Villapudua, who asks, how can California prepare for and mitigate the impacts of drought in the Delta to improve its resilience to disasters? And I believe the first person I will pass this to is Shruti, since you are still on my screen, I know you've done a lot of work with how we might mitigate some of the ecological disasters that are associated with drought, and perhaps you could elaborate on that.
Yeah, so one thing that needs to happen is that during drought years, especially, adaptive management of invasive species becomes very important, because we see that there is a tendency for these species to increase during drought years. So maybe they need to be more aggressively treated during those years. And then there is a lot of, due to the Eco Restore program and other programs, there is a lot of restoration right now that is going on in the Delta. And it is important that these new restoration projects be designed to benefit native species over invasive species. And some of the ways that that can be done is by actively planting native species and furthering, the native species to come in rather than invasive species, and also to treat around the restoration sites so that invasive species don't enter the sites and give the native species a chance to flourish. So those are some of the ways in which these effects can be mitigated.
Thank you very much for that. We hear a lot about nature-based solutions as promoting resilience in California, and I think it's important to note that we really need to put a lot of careful thought into how we deploy those nature-based solutions so that they themselves are to extreme events like drought. I think I will pass it to Josué next to tell us a little bit more from his perspective on what California can do to prepare for and mitigate the impacts of drought.
Yes, as it was mentioned earlier, salinity might have some effects on water treatment and costs and also viability of crops, particularly for some salt-sensitive crops. So studies on the causal effects on salinity on crops can be useful to determine vulnerabilities on this side. Some of that has been done, definitely, and it shows a high level of adaptability to saline conditions by farmers. So areas that are more volatile in terms of salinity levels see crops that are more tolerant. So a lot is already happening, but I would like to bring the point of studying the distributional effects of drought on communities. So how changes in the economic activity due to droughts in some of the areas in the Delta affect the livelihood of people that lives in these communities and the employment and income opportunities that come from it. So I can tell other areas that could help are better water balances. As we know, crops and vegetation, often water uses some of the most part, the majority of the water that gets into the Delta. And having better information on the non-crop categories could be extremely helpful to identify policies that could help mitigate some of the effects on water quality and habitat for native species. So those are some of the areas I think could be helpful to pay attention to be better prepared for the next drought.
Thank you. Very, very insightful. And to complement that, I'd like to pass the microphone to Michelle to give us her perspective on how we could prepare for and mitigate impacts of drought.
Yeah, well, one thing we can all do as Californians is recognize that drought is endemic to California by nature of our Mediterranean climate. We do experience drought every year because our summer months are dry, and it is only because of engineering and infrastructure that allow us to ignore that drought occurs every year. So one thing we can all do, whether we're managers, agency personnel, researchers, or simply water users, is plan and act like every year is a drought. But if I put my researcher's hat on, I would say that having sustained funding for drought preparedness, including research, would be another way to prepare. For example, during the 2012 to 2016 drought, I was involved in research to investigate how surface water salinity impacts soil salinity, which coincidentally, but not by design, occurred during the drought. Often funding is allocated retroactively, and opportunities to learn from critical opportunities can be lost. Furthermore, studies that span the extreme conditions like drought and flood provide these opportunities to understand systems, whether they're agricultural systems or ecosystems. So to reiterate, California can prepare for and mitigate the impacts of drought by developing long-term and sustained strategies and funding to deal with it.
Thank you, Michelle. And I think I am going to go to the next question. I know I didn't hit Daniel with that one, but I think the next question is particularly well suited to him. How common is drought in the Delta, and how is the risk of drought predicted to change in the future due to climate change?
Well, as we've already been talking about, drought in the Delta is very strongly correlated with drought elsewhere in California, and California is no stranger to drought. It is an intrinsic part of the climate here. Depending how you look at it, as was already mentioned, we kind of get a drought every year during the dry season, and that's actually not a common, to have a very, very dry season that coincides with the warm season is actually globally unusual. For anybody who's from elsewhere or travels elsewhere on a regular basis, you might notice this. It's pretty rare to have long, dry summers in a place that isn't dry the whole year round. Usually the winter is the dry season. And so in California, when the water is supplied by nature is exactly the opposite of when it is most needed in a human consumptive sense, and even in an environmental context. Much of there's an excess of water when it's raining, and then the opposite is true in summer. But drought, as more traditionally defined, being years-long periods of unusually dry conditions, have already increased substantially due to climate change, as I mentioned earlier, mainly due to the warming temperatures themselves and the increased evaporative demand of the atmosphere. Essentially, the same amount of water falling from the sky as rain and snow just doesn't go as far as it used to. And I don't just mean that in terms of human consumptive sense. I just mean even on the landscape, in places where there's no infrastructure and no water management, more of that water is evaporating back into the atmosphere earlier in the year, and therefore by the end of the dry season, there's just less available in general. And so, there's some question, I think, at this point, given what we're seeing on the Colorado River, given what we're seeing in California more broadly with climate change, whether or, how do we talk about drought in a climate change era where at least in California, the mean precipitation really hasn't decreased much, but the intensity of droughts and the frequency of droughts has increased considerably already and is expected to further increase with each additional increment of warming. And so some folks have started to call this aridification of the landscape, because it's the overall state of dryness is moving in one direction only. So the idea of a drought is that eventually you emerge from a drought and at least temporarily return entirely to the situation you're in before the drought began. Increasingly, we're not seeing that. And we are seeing droughts that are broken, obviously, by increasingly extreme precipitation or interrupted by extreme precipitation, as we got a taste of this past October, where we had the wettest day in Sacramento and parts of Northern California history in the middle of the singularly longest dry spell in history in exactly the same places. That's kind of a microcosm. Unfortunately, that produced more benefits than harm, I think, in this particular context, because it's been so dry, the rivers were so low that there wasn't severe flooding as a result of it, because it just kind of got absorbed by the landscape for the most part and generated some beneficial runoff. But I think that's the tricky part, is that looking forward to the future, we can't just think about drought in isolation, because there's actually a lot of evidence that the variability of California's hydroclimate is already starting to increase, but especially will increase in the next few decades with an additional, half a degree or degree of global warming over the next few decades, as is very, very likely. That variability is likely to continue to increase. And that includes on the wet side. So one of the things that we are trying to emphasize, even as we talk about drought, even as we experience severe drought in this part of the world, is the rapidly escalating risk of very large flood events at the same time as increasingly severe drought. So even if the landscape is becoming is aridifying overall, mainly due to rising temperatures and not so much due to decreasing precipitation. We still expect those increasingly long and intense dry spells to be interrupted by increasingly intense storm events or storm sequences that can produce the opposite problem. But of course, then that begs the question, might there be a way to co-manage these events in a way that actually helps reduce the harms from both of the events? And I think one of the promising approaches here that's commensurate with what we think the physical climate will look like in California's future is essentially leveraging the floods that we do see periodically and sporadically to recharge our aquifers. And so the state of California calls this FLOOD-MAR, flood managed aquifer recharge. And the idea is you take these essentially windows of opportunity where you have these very large excess flows where you don't know what to do with, or actually if you don't do something with it, it's going to flood places you don't want to flood, and try and move them to places that you've pre-designated as recharge zones, recharge basins. So thereby recharging groundwater, improving resilience against the next drought, while ideally reducing flood risk in the moment to the places you really don't want to flood, mostly the populated urban areas. So that, of course, is easier said than done for a variety of reasons that relate both to physical infrastructure and policy. But that's the kind of intervention that I think is increasingly being talked about. That is, in my view, as a physical scientist on the climate side, is consistent with the kind of future we're already starting to move toward, and that we're really going to start to experience to an even greater degree over the next few decades.
Definitely a worthwhile project for sustained investment. That one of the things I like about the Managed Recharge project is that they truly fill up that sponge, which is our watersheds. And so when we receive rain or precipitation, that precipitation has a likelier chance of running off to replenish streams and aquifers rather than primarily moving down and just filling up that sponge. So thank you for covering that. Of course, the other side of the coin is managing demand. And that is a nice segue into our next question, which comes from Hal McLean, who asks, how can we reduce the human demand on water? So I think I will pass this to either Josué or Michelle. Would either of you like to volunteer an answer to this question?
I can just get started. So Dan mentioned an extremely interesting point on we have a warmer droughts, and with warmer droughts in many places, there could be a higher evaporative demand in crops. So there's this component of droughts that in a way taxes how much water we have to put into crops. So there might be an increased amount that needs to be used for irrigation with droughts. So as this become more frequent in the future, I like to think in terms of a water balance perspective. We need delta outflows. We need to keep salinity controls for agriculture, for cities, communities, and on the other hand, we need increased apply water in the delta draining basins that use a lot of the water that goes back into the delta. So reducing demand is, we should think in terms of reductions in consumptive use. The water that just gets lost to the atmosphere and does not go back to the system, or at least immediately, right, or directly. So it goes into those atmospheric rivers and other things, and the groundwater reserves. Sorry, not even the groundwater reserves. So this reducing consumptive use, cities have done a lot through it. Agriculture has done also its part in terms of increasing application efficiency. But at the end of the day, we cannot make more water, right? And we have to cut back a little bit into this consumptive use that occurs by decreasing these losses that are not going back to the system, such as reducing irrigated areas. This is especially true for places with overdrafted basins, such as the San Joaquin Valley and other areas, the coastal areas, and that might be one of the strategies that we can do to reduce human use. Also, reduction of irrigation of outdoor areas, as we know, probably 40 to 50%, depending on the location of the urban uses in outdoor land, irrigation of outdoor landscapes. So those are some opportunity areas we might want to look into in terms of reducing demand.
Thank you. And I'm wondering, Michelle, if there's anything you would like to add to that response.
Sure, I'll tag on to what Josué started with. I think it's pretty clear to Californians, especially those in the water world, that agriculture is a big user of water in California. And I think, and Josué touched upon this, the Sustainable Groundwater Management Act is going to have a heavy role in reducing agricultural acreage in California, especially in overdrafted areas. I wouldn't say that we'll see a big change in agricultural area in the Delta because of the difference in hydrology in the Delta, where groundwater is in shallow layers of the soil, unlike the San Joaquin Valley, where it keeps falling lower and lower in the soil profile. But overall, in agriculture, there are many practices that we're researching and that growers are employing to try to manage how much water is being used in crops. Those include irrigation methods, including drip irrigation and other forms of micro irrigation. Sorry, my automatic light just went out. And also looking at drought tolerant crops and specifically drought tolerant varieties of crops. So I have colleagues who are not only looking at crop species, but varieties within species that may be able to tolerate higher levels of drought or higher levels of salinity.
Thanks, Michelle. And I'm just curious to learn a little bit more about landowner willingness to adopt these changes in practice and the extent to which you've been engaging with Delta landowners in this research on drought resilient agriculture.
I think that there's certainly a willingness because the writing's on the wall. As I said in a previous response, drought is at least cyclical, if not endemic. And growers are well aware of that. These irrigation practices are pretty widespread. These reduced irrigation or deficit irrigation practices are pretty widespread in the agriculture community, both in the Delta and outside of the Delta. Many of these practices have become recognized for improving yield or improving crop quality, such as drip irrigation in crops like processing tomatoes or wine grapes. So those things make it very easy for growers to see the data and implement the practices. In terms of the other crop or species tolerances that I mentioned before, I think growers will be on board once we have a little bit more scientific understanding. I think these sorts of things will take regional studies where we're looking at not only these species or these varieties in a certain location where they might be developed, but also taking those studies a little bit broader and investigating them both in the Delta environment and in other environments throughout the state.
Sounds very promising. And just for the sake of completeness, I will add that there's also a lot that urban water users can do to reduce demand. And I know that as a resident of the city of Sacramento, there have been incentives, monetary incentives, to decrease grass coverage on individual yards. Grass is a very water hungry land use type. But cities like San Diego have made big strides in reducing urban water demand. So I think this is all quite promising. I'm going to go to our next question, which comes from Judith Drexler at the USGS. And she asks, Recent research suggests that atmospheric rivers will increase in the future under climate change, yet total precipitation is unlikely to increase. How will this increase in the episodic delivery of precipitation affect ecosystems, agricultures, and communities? And I'm going to first turn to Shruti to give us her response to that question.
Yeah, so I'll address the ecosystems and then we can move on to Josué and Michelle for the other two. So that is the problem, is that when you have a heavy flood during a drought, it doesn't necessarily bring about the advantages that it could have, at least for ecosystems. So Daniel was mentioning that for water recharge, it might work well, but hot droughts, especially, we have noticed when flooding happens during a hot period, salmon, which usually love floods and love the yellow bypass to be flooded, get nice and fat in there, do not do that when the droughts are hot and the water is hot. So it doesn't benefit fish as much. So that is one issue. And then the other thing that happens, which is kind of evident from a recent big atmospheric river that went through, and there was a fish kill in Puta Creek. It can sometimes, when the land is so dry, mobilize contaminants in the soil, and the floods bring that along, and it can actually cause more harm to fish. For invasive species, generally, high flows will flush out invasive species. The water gets a little freer of aquatic species. On the other hand, it is also an excellent dispersal mechanism. So it actually spreads out the species by, flowing them out of flooded islands and places where water tends to collect. And then when the next year the flows are lower, then those species already have propagules in there and can be nice and happy and spread again. So overall for ecosystems, this is harder on them than an actual increase in precipitation and colder floods would be.
Thank you, Shruti. And I will now pass it to Michelle, who could talk about impacts of episodic delivery of precipitation on agriculture.
I think this sort of episodic precipitation, or these changes in precipitation over time in the Delta in particular, will be manifest through the changes in salinity that we see of saltwater intrusion. I mean, we see a temporal change in salinity in the Delta just due to the tides. But when it comes to precipitation and flows, that, as I mentioned in one of my opening statements, we see the salinity move further inland. And I think that'll, in the short term, that may manifest as changes in crop yield or quality. In the long term, it may have an impact on what crops are planted in the Delta or what lands can be used for agriculture. I think the question would have different answers in different parts of California, but in terms of Delta agriculture, those would be the impacts that I would envision.
Thank you. Josué, anything to add to this question, or should we move on?
I think just quickly, I mean, one way of seeing this is we have warmer droughts, and Daniel might correct me if wrong, but we might see more precipitation, precipitation that is not snow, that it won't be in the form of snow. So this opportunity to bring these flood waters in wet years into the underground can make up for this loss of our largest surface water reserves in the Sierras for the summer irrigation and other water needs. So, seizing the opportunity to store water underground is I think is a good avenue, and some rapid guidelines for that occurring are needed.
Great. Thank you. And we do have another question related to the episodic nature of the increasingly episodic nature of these precipitation events that we're seeing in California. This question comes from Douglas Akahoshi. Thank you for the question. He asks, do the high precipitation events mentioned by Dr. Swain reverse the increased soil salination caused by the drought? Michelle, would you like to take this one?
Yeah, unfortunately, we can't say that with certainty. We can probably make some assumptions about that. Certainly the rainwater, we rely on rainwater to help us leach salts out of the soil profile. But due to the hydrology of the delta, particularly the shallow groundwater, sometimes we find that to be a barrier that prevents leaching of salts out of the root zone. So we may have a lot of rainfall that comes down, let's say in the 2016-2017 rainfall year that we had that followed the drought. So we did see soil salinization increase during those drought years in certain studies that I was involved in. Unfortunately, the study didn't go into the next year due to funding and other constraints. So we would hope that and assume that the soil would get cleaned out to some extent of those salts that had built. But due to these hydrology issues and also just the heterogeneous nature of soils, where soil layering or soil texture differences may actually hinder leaching of salts out of the root zone. So I don't have a very conclusive answer, but it's probably yes and no.
A really interesting question and a great answer. You know, I would say, from my perspective, the management of salinity in the Delta is one of the, if not the biggest challenges in managing the suite of conditions that we experience during drought. Michelle and I are both engaged in planning a series of workshops to look to the next big drought or extended drought conditions in California to develop a very forward-thinking strategy for how we manage salinity and assess the impacts of those management strategies on a whole host of sectors, including agriculture. And this issue of soil salination is one of the big uncertainties that keeps coming up in the planning discussions. So thank you for the one of the things that we haven't talked about very much in terms of this discussion and talking about how changing climate is going to impact the Delta and California at large is sea level rise. So how will other climate change impacts like sea level rise or higher temperatures impact the Delta during drought conditions? Daniel, would you like to provide us with some of the physical context to thinking about this question?
Sure. I mean, sea level rise is an interesting one when it comes to the Delta for a couple of reasons. First of all, I think some folks may even forget that the Delta is directly connected to the ocean. And so if the sea level rises, the water level in the Delta is going to rise essentially by the same amount, the tidal cycle notwithstanding. So the Delta, is already very low lying, and absent levees, much of it is below sea level or would be below sea level. And so you have this place that is connected to the ocean that is below sea level. If you think about that for a minute, that could result in some problems if the ocean level rises, which it is. The ocean level has already risen, but it's doing so in a very spatially heterogeneous way globally. So sea level rise is actually, and that even as a climate scientist, when I first found this out, this was somewhat surprising, is very different from one place to another. So you might think that a rising sea raises all ships evenly. It does not. And not only does it vary in space, it also varies in time. And so we have higher sea level when the North Pacific Ocean is particularly warm. So there's variations with La Nina and El Nino events, for example. There's decadal oscillations. But overall, the ocean level is obviously rising because of climate change, partly because of just the thermal expansion of water, but primarily, and especially this will be especially true as we move through the next few decades into the middle part of the 21st century, due to melting ice sheets. And the melting ice sheets part, that's accelerating. That's a nonlinear process. The challenge is we don't know how much it's going to accelerate further. So sea level rise today is already faster than it was a decade or so ago, and is likely to be faster a decade or so from now. But that's sort of where the tricky part is, because while we often talk about median estimates for how much the ocean level is likely to rise, those estimates are very asymmetric. At least the uncertainty in those estimates is asymmetric. So it's not like we're equally uncertain that sea level rise could be lower than expected or higher than expected. There's almost a 0% chance that sea level rise is going to be less than expected. And there's a pretty reasonable chance it could be significantly higher than expected. So the uncertainty with respect to sea level rise is very asymmetric about the median, meaning that the upper tail, the extreme sea level rise outcomes, are much more likely than the very low sea level rise outcomes. So how do you plan for that? This is, of course, a problem anywhere along a coastline globally, but in the Delta, it's especially challenging because we do have the system that's critical for the environment, that's critical for agriculture, that's critical for the transport of fresh water north and south through the state. So how do you deal with uncertainty when you know that the very worst outcomes are more likely than the very best outcomes, but we can't really put a number on it still, since that's actually one of the biggest challenges. And I don't have any good answers for that other than to really emphasize that the upper end of the outcomes are potentially a lot higher than the median.
Thanks. Really, really sobering to hear that. Before we go to a wrap-up question, I would like to also pass this question to Josué, who could tell us about how rising sea levels during drought conditions might impact water supply and water deliveries to the rest of California.
I think Dan covered this very well. And the main concern is, or one of the concern is flood management. The hydraulic pressure raises on those levees that surround many of the areas in the Delta, and also the pushback of the salinity line in the Delta to protect water quality for in-Delta water uses and Delta exports. So again, we need to be really prepared for how that is looking in the future. What Dan just said looks more like on the upper end is more likely. So that is an area of we should focus on efforts.
Yeah, so just summarizing, sea level rise really compounds the challenge of rising salinities in the Delta around water intake points for ecosystems that we already are experiencing during drought. I believe Shruti has a bit to add to this question as well. Shruti?
Yeah, I just wanted to mention that the other thing that sea level rise, especially if it's towards the upper end, as Daniel was mentioning, is likely to increase the pressure on our existing levees, which increases the chance of levee breaches within the Delta. And then because the Delta is so subsided, that increases the chance of quick kind of filling up of a bowl of saline water, which can lead to very severe impacts that might take years to then flush out. So there are definitely more risks associated with sea level rise depending on where it lands.
And I should mention that just since this is a briefing about resilience, one of the efforts that's ongoing in the Delta to mitigate that particular challenge is wetlands are being created and designed specifically for subsidence reversal. Wetlands are incredibly effective at helping to fill in that bowl through natural processes. And so continuing to invest in wetland restoration is one of those things that could promote resilience to these challenges. Well, we only have a few minutes left, so I'm just going to pose a really quick wrap-up question to the panel, which is, what are some of the biggest knowledge gaps that still need to be addressed? And since we do only have a few minutes left, I would take a volunteer from the panel who would really like to address this question. Do I see any? I can't see all of your faces, so please just go ahead and start speaking if you would like.
I'll take it first, Laurel, because I can answer it really succinctly. Douglas's question earlier in the session really hit the nail on the head for me. I think that understanding how surface water salinity impacts soil salinity and the long-term impact of soil salinity on agriculture viability is a lingering question where we need to do some more work.
Great, I agree. Shruti, would you like to respond next?
Yeah, I guess a couple of things that are very important to consider is how can we create temperature refuges for our fish communities so that they can survive what is clearly coming in the future. And then also a lot of habitat modeling needs to happen with regards to invasive aquatic species so that we can predict and manage the risk of the spread of these species so that we can keep the habitat more conducive to our native species.
Really important. I've recently been looking at statistics as to how many millions of dollars are spent each year on California on invasive species management and how many billions of dollars are spent US wide. So really, really critical. Josué, would you like to contribute before we wrap up?
Sure. Water balances, I think it is always an all-time favorite. I think just quantifying water use in crops, in floating vegetation, open water, and how this is likely to change with more extreme climate. So this is some areas in which we could put in some efforts.
Thank you. And last, I will turn it to Daniel. We have about 1 minute.
I think that one of the biggest uncertainties when it comes on the climate change side is there are, of course, climate model uncertainties, climate science uncertainties. We don't know exactly how much precipitation may change or exactly how much it may warm. But really, one of the things that dominates the uncertainty is uncertainty about how much the globe, the whole planet as a whole, is going to warm. And that's not really a scientific uncertainty, primarily. That's a question about global policy and global carbon emissions. And the reality is the Delta and the rest of California is going to experience an amount of climate change that is largely dictated by what happens in other countries around the world. California, of course, can be a leader in mitigating climate change, but ultimately it's still going to experience that same amount of climate change if the rest of the world doesn't also follow suit. So, it's sort of a regional and local manifestation of a global challenge. And so one of the greatest uncertainties is what we do with that globally. How much more carbon do we emit? How much more global warming is there? How much more will the Delta change from a climatic perspective moving forward? So that's something we don't know. It's something that we have control over collectively. And that's one of the most important things to remember, is that this is a challenge that is not a foregone conclusion. The reason we don't know how much it's going to warm is that we can make decisions that cause it to warm a lot less than other decisions. And so I think I'll leave it at that.
Very compelling note to leave us on. Thank you to the panel for joining me today. This has been a really enjoyable discussion. Thanks to all who submitted questions. And I will now turn it back over to Sarah Brady.
Thank you, Laurel, and thank you to all of our panelists. That was an excellent discussion. Thank you to everyone in our audience who joined us today. If you'd like to watch this briefing again or have a colleague who was interested but couldn't make it, it will be posted on our website along with the one-pager and the contact information of the panelists you heard from today. And please join us at 3 p.m. Pacific time next Wednesday, December 8th, for our next expert briefing on remote sensing technologies and water resilience. Thank you. Have a good day.